So we've got our satellite and all the different components of it. Our GPS, it takes batteries. We've got extra batteries for everything, including our GPS. We've got backup batteries for everything we've got, and we've got spare backup batteries, including spare desiccants and everything we need. What we'll then do is we take our balloon. We've got a 1,200 gram balloon that we've purchased, and it will take about 150 cubic feet of helium to get it to the right buoyancy to take our balloon up. So we have rented a balloon cylinder that's 200 cubic feet, and we have now got that in our possession. And along with our cylinder of helium to send off our balloon, we have a filler nozzle that's made from PVC parts that you can get from any hardware store, and a nozzle that will fit into our tank, our 200 CF tank. And we will take tarps and a blanket and a number of things out to our site. Try to, as best we can, to find a site with little or no wind. We will lay out our balloon and start to fill it up. In order to seal our balloon, we will first start off with rubber bands and do the loop twirl technique. So we loop the rubber band around it a couple times, twist it, loop it around again, twist it. If anybody has a ponytail that they put rubber bands on, it's much like that. Once we get it a number of rubber bands on our filled balloon, we will put this ring in it, bend it over, and tape it, and we'll have a nice ring that we can connect things up. We will find out how much exact helium we will need in our balloon by using a little bit complicated method. We have a luggage scale here that is used to weigh luggage. We will weigh our entire payload and find out how heavy it is. We will then take water and put it in a milk jug to that exact weight. We will have that milk jug ready as we're filling up our balloon, and what we will do is fill up our balloon so that it lifts that water jug fairly easily, but not too much. One of the key things about doing this ballooning that we found out is that you need enough helium to get it up there and reasonably quickly, but the more helium you put in your balloon, the bigger it is, and therefore the balloons have a burst diameter. So they don't care how far up they are, they just care how big around they are, and as you go up further they get bigger and bigger. If you start off with a lot of helium at onset, then it will go up not as high before it bursts. So we want to get just the right amount of helium to lift our package, which will be about 5 pounds. Right now our weight is at 5 pounds exactly. And so we will put enough helium in to lift that payload. We have a number of devices that will go in a row. First, of course, we have our balloon. The next thing we have is our parachute. And we have purchased a parachute that is used for rocketing. And it didn't have a ring at the apex, so we had to sew in and tape in a ring at the apex. This parachute we purchased is also bright orange because it's part of our fail-safe method. We want to be able to find this. This parachute will attach to the balloon with a short lanyard, 50-pound test, 50-pound cord. That'll be about 4 feet long to make sure it's out of the way and ready to go. We'll have our parachute, and then the other thing that we need is a radar reflector. The radar reflector in our case is cardboard, and it's metal covered cardboard so that it's nice and light. And we have a 4-foot line on each side of that. So we'll have our balloon, then we'll have our parachute, then we have our radar reflector, and another 4 feet on the other side of this, and then we connect to our satellite. Our satellite also has its own cabling, so it's ready to go and can hang so that when both sides are ready to go, it will be ready to hang, and it cradles it from underneath. I've seen a number of designs where they have a pin down the center and a washer. I thought for this styrofoam box like that, that might be a little dangerous. When the balloon pops up at about 115,000 feet, the parachute is just dangling and will deploy immediately. The problem is there isn't much air up there. It's almost zero pressure and zero oxygen, almost no air. And so even though the parachute is deployed instantly, there's not much for it to resist. And so the payload will get to be going approximately 150 miles an hour for a time until it gets into denser air and starts to slow down. So anything you do up there has to be able to withstand that vibration and speed. So we wanted to make sure we cradled our payload quite well and made it pretty sturdy. So we put the strings underneath it. We got our payload there. We'll connect all the different pieces together with various carabiners, and if we use the spring-loaded carabiners, of which we've got a couple because they'll make it very quick, we've got some screw-on ones, but where we've got a spring-loaded one, we'll tape that as a last precaution to make sure nothing comes loose. We've also got tie wraps available if we need them when that comes up. So we've done a number of projections. We have an idea from these projections of where we want to launch. We live in a place called Lake Stevens, Washington, that is in western Washington, that is sandwiched between two mountain ranges, the Olympic Range and the Cascade Range, and a lot of water, as you can imagine, in the area. We live next to a lake, and we live next to the Puget Sound. And so if we launched the balloon from here, if the wind was heading west, we would end up possibly 150 miles into the ocean, or at least into the Sound. And if it was going east, we would land somewhere in the Cascade Mountain Range, which is inaccessible except by mountain goats. So we've decided to take a short trip across the mountains to the east, to the high desert, to the place called Ephrata, and that has fairly predictable wind patterns, even at the upper atmosphere. And we'll launch and hopefully land in the high desert about 100 miles to the east of where we launched. So we'll do our projections at the last minute as we get ready, and we'll do our launch, and then we will all hop in our tracking van and track our balloon until we get it back. Hopefully we'll be able to see it during the entire flight, but we'll have multiple ways that we can track our balloon to go find it. So we're really looking forward to the balloon challenge. Our goal in this was to make a balloon that was highly repeatable, that was off-the-shelf materials to use. So we've purchased everything that we've got, either from an electronics store locally, through Amazon, through a local hardware store, or just stuff we had around the house like key rings and that. So everything from our silicone gel to our rubber bands, we've got locally as much as we can. The idea of this is that we want to make this instruction for people so that everybody can build these and so that everybody can get the materials and all that. There are a number of ways of doing this, but if we use off-the-shelf materials, things that are readily available to almost anyone, then more people can enjoy sending a balloon to near space and bringing back video so that they can see it. Good luck to all the other teams. I'm really looking forward to sending off our balloon and also seeing the video from other balloons as well as what other teams have done. Thank you.